The second rule that we're going to talk about is called the power rule, and this deals with having an exponential expression that's raised to another power. For example, if I have x to the second, and then that's raised to the third power. Okay, let's think about what that means. This actually means that you're multiplying x squared times itself 3 times, right? X squared to the third power means you're multiplying x squared times itself 3 times. So if I go back to the product rule, what would it tell me to do with these exponents? X squared times x squared times x squared, we would add up the exponents, so it would be x to the sixth. Okay, again, if our numbers get larger, we don't want to have to do that every single time. So the power rule kind of gives us a shortcut. And here's our definition for the power rule. It tells us that if you want to raise an exponent to a power, keep the base and multiply the exponent. So when it says keep the base, that means keep the x, like I did right here, and then just multiply the exponents, because what would 2 times 3 be? It would give me the 6. Okay, so the way that I kind of remember this one is these are the ones that you're going to have parentheses with. Okay, so if we look at some examples, if I have x to the fourth in parentheses to the fifth power. Okay, think about, parentheses with the distributive property that we did earlier. If you have parentheses, we always say multiply, get rid of the parentheses. We'll kind of stick to that same rule here. Multiply to get rid of these parentheses. So this would just be x to the 20th power. Okay, so if I have, let's say, x squared raised to the 10th power, then this would be what? X to the 20th, again, okay, multiplying the exponents. Then if I have more than one variable, let's say I have x squared, y to the third, and all of that is in parentheses, raised to the fourth power. This is actually kind of a break off of the power rule. This is called the power of a product rule, where you have a product in the parentheses that's being raised to an outer power. But it still falls under power rule. We have something in parentheses raised to another power. So that means each term or each exponent here will get multiplied by this outer power. So I would have x to the 2 times 4 would be 8, and y to the 3 times 4 would be 12. And then that would be as far as you can go, because these are not like variables. It would just be x to the 8th, y to the 12th. Okay, on these three examples, what have my coefficients been? What are my numbers in front of these variables? Understood 1, understood 1, understood 1. Well, what is 1 raised to any power? Okay, like up here in part A, 1 to the fifth power is still 1, so that's why we don't see that coefficient. But what's going to happen when that's not a 1? Okay, let's look at those. If I have something like 5x to the third in parentheses to the second power. Okay, it still means everything in those parentheses have to be multiplied by, or have to be raised to the second power. The 5 actually has an understood 1. So what am I going to get if I multiply the exponents? I'm going to get 5 to the second power, and then I'm going to get x to the sixth power by multiplying the exponents. But what is 5 to the second power? If you get a number raised to a power, you're going to need to simplify that. So 5 to the second power is 25, x to the sixth. So that would be your final answer. So what you've got to remember is if there's a number here in front of your variable, it's going to be raised to this outer power also. Okay, so can't forget about that, especially if you have, let's say, a negative number. Here's an example that you might see: negative 2, x to the fourth, y to the second, z. Okay, lots of variables in there, all one term raised to the third power. Okay, if it helps you, when you have a leading coefficient like this negative 2, put a 1 on it if you need to. And know that you're just multiplying exponents. You're not multiplying 3 times 2, but you're multiplying 3 times the 1. Okay, multiply the exponents. So that would be negative 2 to the third power. X to the 4 times 3 would be 12. Y to the 2 times 3 would be 6. And Z also has an understood 1. So 1 times 3 would give you Z to the third. Okay, then if you say, okay, I have a number here raised to a power, I have to simplify that further. So this would equal negative 2 times negative 2 times negative 2 would be negative 8, x to the 12th, y to the 6th, and z to the third. Okay, so this is what we call our power rule. If you have an exponential expression and you want to write it or simplify it, you're going to multiply the exponents. Okay, let's look at one more example that I see. If you have xy in parentheses to the fifth power. Okay, again, go in and write those understood ones if you need to. And that's what you're multiplying. X to the 1 times 5 would just be x to the fifth. Y to the 1 times 5 would just be y to the fifth. So that would be your final answer. Okay, so this is our power rule that we're going to use for exponential expressions.